Hey everyone here. I'm going to explaining the challenge questions. Wait a minute. I'm gonna explaining the daily challenge questions from which is finding the minimum number of vertices to reach all the nodes, which is a 1557 LeetCode questions. Okay. So give a direct acyclic graph. So what do you mean by acyclic graph? This means such that you can see from the graph out here, using 0 to 1, 1 to 0 to 1, there's only 0 to 1, not 1 to 0, right? Okay, that is acyclic meaning, okay? It started from 0 to n minus 1, which is have a 6, which is basically 0 to 5, which is nice, right? And then representing the okay, so give me array is from 0 to 1, 0 to 1, 0 to 2, 0 to 2 in these cases. Okay, and this question is kind of like it's definitely is gonna be the graph questions, but this graph questions actually is not that kind of crazy. It's kind of like so obviously once I think I actually think about this question for so long, but after that, I finish my submissions first. Let me show you how I improve my solutions based on my after doing some observations here. First time we go 94 milliseconds, and then this time we go 68 milliseconds, and then the last time the really a final time I got is 11 milliseconds. Not the final time, but in between, something in between here. Something in between is 31 millisecond, and then eventually I optimize to 11 millisecond these cases. Okay, so let me show you how I approach this question that how maybe give you some kind of a understanding that what this question are trying to show us how this question guide us to solve it. Okay, let's gonna see something here. Okay, as you can see, I just leave the stuff here. So the question say, um, starting from which node? Starting from the node using the least node, you're going through all of the nodes here. So the question saying, let me just start from a question here. The question says 0 to 3, right? Because you can start 0 and 3 to go through every node out there. Let's see how you achieve it, okay? 0, 1, you can go. 0, 2, 2 can go 5. We're basically done. Okay, we go another row. 3 to 4, 4 to 2. So the minimum rows is 0 and 3. Okay, but why they not picked? They only pick 0 and 3, not the others. For example, not pick 1, not pick 2, not pick 4, not pick 5. Let me show you why the question only pick 0 and 3. So let's make some list here. Okay, let's make some list. So if we start from 0, okay, we can go 0, 1, 2, and 5. This whole route we can do that, right? Starting from 1, you go nowhere. You're starting from 2, you only can go 2 and 5. This cases. If you go 3, you can go 3, 4, 2, and 5. If you go 4, you can go 2, 4, 2, and 5. Okay? As you can see here, okay, the solution is not saying what is the minimum numbers of nodes that I will use to go through all the nodes for this graph. And definitely I'm gonna pick 6 of them because I'm gonna pick all 5 of them these cases. 0, 1, 2, 3, 4, 5. Oh, sorry for that. If the question saying 5 goes nowhere. If the question say if I can how many nodes, not the minimum nodes, I can step, I can reach all the nodes in this graph. You know what I'm gonna pick? I'm gonna pick the easiest one. I'm gonna pick or 6 of them as my final result. Why not? Because all one time, 6 of them, return n, that's it. But the question say we need to find the minimum values, minimum number of nodes that can traverse through this whole graph. And that is the point. We need to consider something. We need to do some observations here. Okay? Alright, let's go now do some observations. Why we start 0? We're gonna do some comparisons, okay? We're gonna compare 0 and 2. Okay? So 0 and 2 here. Okay? Why they pick 0 and not 2? Because that is something is obvious. That's really obvious here. Because 0, the road that 0 can go, 2 definitely can go. And once 0 already go to, for example, if you're 0 going to the road 0, 2, and 5, what is the purpose you need to redo again for the segment 2 to 5? What's the purpose? That already 0 has already done the job that you're 2 doing. So this meaning saying that if 0 has do the job, 0 has finished the job, of 0 to 2 to 5, then 2's job 2 to 5 is unnecessary. Is unnecessary anymore. So, and that is the case that all those intermediate point we don't need to worry about anymore. So 2 is don't need to do it about it. 1 go nowhere. But as a same reason, 0 can step into 1. And then 1 itself don't need to finish the job because 0 has already done the role. So 0 no longer needed. Okay. What about 4 to 5? 3, 4 to 5, 4 to 5. Same thing. 3 finish the row job. 3, 4 to 5. That's representing the row of 4 job. 4 to 5 is no longer needed. Same as a 5, because 5 itself. Oh, so I said I'm gonna try something here. 1 can go 1, 5 can go 5, no problem. Okay, so back to here again. Because 0 can go into 0, 1 road, means 0 do the job of 1. And 1, since 0 has finished the job, then 1 no longer need to do the job anymore. So 1 is being eliminated out. 5 is the same reason, such that 3, 4 to 5, 3 has do the row job, 3, 4 to 5, and thus 4 to 5 out of 4 no longer needed because 3 already finished this like a traverse. And also, of course, a 5 this does not need to do the job because 3 has already finished it. And that is 0 and 3 left. But what is the characteristics of those 3? Well, as you can see, obviously, all the question now here is 3 and 0 has no entry. They only have outgoing. They only have outgoing. Okay, so this question now is turning to whether we can gonna finding some. Let me say the question now is turning from the graph problem become we need to just count how many of those no entry nodes in the giving graph. Okay, and that is the key ideas. Let's back to the question here again. Let's get back to Java here. Okay, since we have let's restart it here. Okay, so first thing we start coding these cases. We're gonna check the constraint whether there's some corner cases. Then we're ruining what we're doing. It's obviously the same. N is no possibilities that go into below 2, which is nice. Edges definitely has a 1. Edges length definitely does not go within self. Okay, cool. Edges length equal 2, so it means it definitely go to somewhere. It does not say where they are. Great. Okay, and in this cases, which is nice from I to I here, is definitely, since n is not less than is greater or equal than 2, definitely here, definitely the edges does not give us a new or empty list, which is nice. All pairs are distinct. Awesome. Okay, all pairs are distinct. That's really a good sign in this case. So we don't need to worry about these like no crucial corner cases in this question. Well, probably if it's some this question happened on the oh, it's not crucial. How do I spell crucial? No, crazy corner cases example. During the interview, I really hope you need to communicate with the interviewer to make sure all the constraint, all the corner cases you have been covered, because they set a lot of trap for you guys for this. Okay, so we're gonna say first. I'm gonna try is we definitely need to make our results, right, integer, because that's what we're gonna return. Results equals to new array list. Okay, this no what happened. Okay. Okay, second, what we're gonna define is something here, because we're gonna talk about we're gonna find a way to determine whether the node is a intermediate, or it is a starting point, which means no entry. So since the Java's function, whatever default value of a Boolean array is a false, they are gonna make a name Boolean, okay, Boolean array 1D, not entry, equals to new Boolean, okay, which is the size of n, which is really nice. That is really a nice part, okay. New Boolean, so what you're saying is all false, not entry, wrong. Means all so far all the nodes here, so all the nodes are the entry nodes. Okay, then we start doing something, okay? We're gonna do, I'm gonna iterate through a list integral, integer, or something called like a list, also called a pair. Edges, which is nicest cases here. How I say, okay. We only need to care about the second second elements of the list, because this key representing this value is intermediate or not, because intermediate node can have outgoing port as well. You can see here 2 has an outgoing port to 5, but 2 is intermediate because it has entry. So we only care about the second element in these cases. So we're gonna try. We're gonna make a name go to equals to how I say pair dot get 1, not get 2. Okay. We're gonna try is not entry dot what dot go to. That's the really a brilliant part of using integer in this case. Is I like this so much. Equals false, equals true. All right, what's the meaning of this value here? Not entry node. Yes. Oh shit. Sorry for this. Not entry. Yes. 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 It is no longer a entry node, since it has a entry. Not entry nodes. Oh, it has entry. Non-entry. I say non-entry nodes. Okay, now we know we done. We're basically done here. I equals was like what is something well though. I equals something. I equals 0. I less than n. I plus plus, which is nice. If that is easy now. If entry. If not entry. False. True. Okay. Oh yeah. Entry, not entry, I. Because what it means not entry I means wrong. All the nodes are entry nodes. Means not entry is false. Means that we finding an entry node. So results dot add what at I. And then eventually we're gonna return results. And just submit it. Here we go, 11 milliseconds. Well, I don't know how to get faster because I see some others. Let's see what other can go something really fast. Oh man, that's a crazy. Oh my goodness. Oh wow. Alright, never mind. Alright. Thank you so much.